Hey everyone, welcome back to Brainy Lab. Today we're diving into a super important science concept that affects everything around us, the law of conservation of mass. So what is the law of conservation of mass? In simple terms, it says this: mass cannot be created or destroyed in a chemical reaction. That means, no matter what changes take place, the total amount of matter stays the same, meaning that during a chemical reaction, atoms are neither created nor destroyed, but they are just rearranged. Therefore, the total mass of the reactants must equal the total mass of the products in any closed system. This principle applies to physical changes, such as melting or boiling, as well as chemical reactions. Imagine you mix two substances in a sealed container. They react, fizz, or even change color, but if you weigh the container before and after the reaction, guess what? The weight stays exactly the same. The French scientist Antoine Lavoisier first discovered this principle in the 1700s. He's often called the father of modern chemistry. Lavoisier demonstrated that even when substances change form, such as from solid to liquid or liquid to gas, the total mass remains constant as long as nothing escapes. Important note, this law only applies in a closed system, meaning no matter or gas can escape. If you do a reaction in the open air, some mass might seem to disappear, but it's just gone into the air. Let's consider a classic example: the formation of water. After the reaction, we produce 36 grams of water. Mass is conserved. Here's another example: the combustion of magnesium. In this reaction, magnesium combines with oxygen from the air to form magnesium oxide. If done in a closed crucible, you'll observe that the mass of the solid increases because oxygen atoms from the air are now part of the product. The law of conservation of mass is the reason we balance chemical equations. Each atom has mass, and because atoms are neither created nor destroyed, we must ensure the same number of each type of atom exists on both sides of the equation. This also relates to stoichiometry, which allows us to predict how much product will form from given reactants. To summarize: 1. Law of conservation of mass. Mass is constant in chemical and physical changes. 2. Applies only in closed systems. 3. Proven by Lavoisier in the 18th century. 4. Supports the need for balancing chemical equations. 5. Essential for stoichiometry and quantitative analysis in chemistry. Thanks for watching. If you found this helpful, don't forget to like, subscribe, and hit the notification bell for more advanced chemistry tutorials. And remember, in chemistry, nothing just disappears. It all adds up.